Welcome to The Explainer. Today, we're tackling a massive, kind of invisible problem that's really holding AI back. And we're going to look at a new open standard that might just be the solution we've all been waiting for. It's called the Model Context Protocol, or MCP for short. And honestly, it could completely change how AI interacts with, well, pretty much everything.
Okay, so here's what we're going to cover. First, we'll dig into this big, messy integration problem that's tripping up AI everywhere. Then we'll introduce MCP as the hero of the story, the universal connector. We'll pop the hood to see how it works, walk through a real-world example, and then, get real about the challenges. And finally, we'll look at the seriously cool future this thing could unlock for AI agents.
All right, let's kick things off with Section 1, AI's big integration problem. This is really the core issue we need to understand first. So, have you ever stopped and wondered why it is so incredibly hard to get your AI model to just talk to your other tools? I mean, something as simple as connecting it to Slack or your company's database. It feels like it should be easy, right? But in reality, it's this huge, frustrating mess of custom engineering work every single time. Well, the reason for all that pain is something developers call the M by N integration problem. Just picture it. You've got M different AI models on one side and N different tools on the other. As it stands today, you have to build a totally unique, custom-coded connection for every single pair. It creates this incredibly tangled web of code that's super brittle. And by brittle, I mean if you update one little thing, the whole system can just fall apart. It's an exponential nightmare to manage. So how in the world do we untangle that web? Well, that brings us right to our next section. MCP, the Universal Connector. And the proposed solution is the Model Context Protocol. At its core, it's an open standard that's all about creating a single universal language, a standard way for all AI models and all tools to talk to each other. The big idea here is to completely decouple the AI from the tool it's using, to just separate them once and for all. Honestly, the best way to think about it is this. MCP is basically trying to be the USB-C port for AI. You remember, right? Before USB-C, we all had that one junk drawer just overflowing with a million different tangled cables for every single device. It was chaos. Well, MCP wants to do the exact same thing for AI integrations, create that one beautiful standard that just connects everything. And this, right here, is the magic. This is the core value. We go from that ridiculously complex M times N problem to a much, much simpler M plus N equation. So what does that mean? It means if you're a tool builder, you make your tool MCP compliant just once, and boom, it works with any MCP compliant AI. And if you're an app developer, you build your app to speak MCP, and you instantly unlock this entire ecosystem of tools. It's a game changer.
Okay, so this all sounds great in theory, but how does this universal connector actually work? Let's get into the nuts and bolts of it.
So the whole MCP architecture is built on three distinct roles, and they all work together in a kind of triangle. You've got the host, the client, and the server. And really, if you can get your head around these three parts, you'll understand exactly how it all clicks into place.
All right, first up, we have the host. This is the app you're actually interacting with, right? Think of an AI-powered code editor like Zed, or maybe a desktop chat app like Claude Desktop. It's the thing that contains the large language model, it's where you're typing your prompts, and it's basically the conductor for the whole orchestra, telling everyone what to do. Okay, next is the client. Now, you can think of the client as the bridge. It's a component that's usually embedded, kind of hidden inside the host. And its job is all the technical heavy lifting. It's responsible for finding and talking to the different servers out there. It's the part that essentially goes up to a server and asks, hey, what tools do you have? What can you do? And then it handles all that communication.
And that brings us to the third piece of the puzzle, the server. This is the thing that actually exposes a tool or capability to the network. It's basically a software wrapper that you build around, say, your company's private database, or maybe the public GitHub API. And once it's wrapped, it makes all the functions of that tool available to any MCP-compliant app that wants to connect to it.
All right, so that's the theory, the three main parts. Now let's put it all together and see how this whole thing actually plays out with a real-world example.
Okay, let's imagine a simple library book query. So, step 1, you, the user, type in check for ISBN 12345 in the library database. The host, where the LMM lives, sees that and understands what you're trying to do. It then tells its embedded client, hey, go find me a tool for this. Next, the client goes out, discovers a server that has a check availability tool, and calls it.
The server then gets that request, goes and queries the actual database, and sends the answer back. And finally, the host takes that answer from the server, feeds it right back into the LLM's context window, and the LLM gives you that nice, simple reply. Good news, there are 5 copies available. See? It's a totally seamless flow, all orchestrated by the protocol behind the scenes. But look, MCP isn't a magic bullet that solves every single problem. It's a powerful tool, for sure. But like any tool, it's really important to know when to use it and, just as importantly, when not to. So let's get into the practical realities here.
So the crucial thing to remember is this. You'd want to use MCP when you're building interactive AI tool integrations, especially in a world where you might have multiple different AI models that all need to use the same set of tools, and those tools are changing all the time. On the flip side, you probably want to avoid it if you just have a super simple one-off integration. Or if you're doing massive, non-interactive batch jobs, where flexibility doesn't matter and raw, absolute speed is the only thing you care about. In those cases, MCP might be a bit of overkill. And of course, when you try to take something like this into a real production environment, you're going to run into some key challenges. First up is scaling. Going from a simple one-to-one connection on your laptop to something that supports thousands of users. That's a big jump. You'll need to think about things like gateways and connection pooling. Second is security. The protocol itself doesn't handle authentication, so that's on you. You have to secure the connection and set up your own boundaries. And third, debugging. Trying to track down a problem in a live streaming back-and-forth conversation is just way more complex than looking at a simple REST API log. Okay, now this is where things get really, really exciting. Let's zoom out from the technical details for a minute and talk about the bigger picture, the future of AI agents that a protocol like this could make possible. You see, by creating a standard way for things to communicate, MCP stops being just another developer tool and becomes something much bigger. It becomes a foundational piece of infrastructure for what we all think is coming next, true AI agents. I'm talking about agents that can seamlessly and reliably interact with any tool in the digital world, discovering what they need on the fly to solve problems without a human having to hand code every single connection. And this really leaves us with one final big question to think about. What will you build when any AI can talk to any tool? What becomes possible when that fundamental barrier of integration, that tangled web we started with, is just gone? That's the future that MCP is trying to build.